In this video, as we begin our look at object inheritance, interfaces, abstract classes, and polymorphism, I'd like to take some time to just talk about some basic terminology that we'll be using as we continue to learn these concepts. So the first term that I'd like to talk about is called upcast. Now, when we talk about an upcast, what we're talking about is we have a base object or a superclass type. Now, that object will contain the basic properties that we'll be using that will be inherited to all of the subclass or children of that superclass. As that happens, then we have the extending subclasses, and those classes will have more unique properties or be more specific than the base class or superclass. So in order to go from a more specific object type to its supertype, we need to upcast it. Now, the nice thing about upcasting when we work in Java is that upcasting is done inherently. So we can easily change from a more specific type to a less specific type using an upcast without having to do anything special in code. Now, the second type of casting that we're going to look at is called downcasting. Now, a downcast will happen if we need to go from a less specific type to a more specific type. This will be going from the superclass down to one of the extending subclasses. And so in order to do that, we have to perform a downcast. Now, in Java, as we program, in order to go from a less specific type to a more specific type, we will find out that we have to do a little bit in code using what's called a typecast. And we'll do that by placing the type in parentheses in front of the variable or object we're trying to downcast. And we'll see that as we continue to work with code throughout the unit. So the superclass or base class is the parent object. It has the minimal type definitions that define that object. For example, we might have a person. That person would be the superclass and would have name and age. And then we might have a worker underneath the person, which would be a subclass. And that subclass might contain a salary. So the top level class is the superclass or base class, and that class has the subclasses or children that extend it. So the subclass then is the extension of the superclass, which adds more specific behavior, usually more unique properties that would be defined to a specific type of the less specific type. Like I said, we had the person before, and we needed a more specific person that was a worker who had a salary. Still a person with a name and an age, but now they also have a salary. And so we would have that subclass worker under person. And we could upcast from worker to person without having to do anything special. And we could downcast from person to worker by using that typecast, placing worker in parentheses in front of the variable name. The next term I'd like to talk about is overriding. When we work with our inheritance, we're going to have the ability to override specific method implementations. So our parent class or our superclass or our base class, that object will have a method in it that's defined or maybe stubbed out that needs to be defined more specifically in a more unique version. And so we override it by having the same exact method signature. One of the best examples that we'll see in overriding is that we'll have toString, and the toString will be overridden in our subclasses because we need to be more specific about the state of our objects as we become more specific objects. Another way that we can create methods in a subclass or even in a parent class is by overloading. Now, when we overload, what that means is we're going to have the same name, but then we might have multiple versions of that method which differ based on parameters. So what will happen is then we'll have different methods with the same name, but they'll have different signatures because they'll have a different list of parameters that we pass into that method. And that gives us multiple options that we can use in order to make a method work a specific way and have similar methods, but sometimes they take different parameters. And one great example of overloading that we'll see right away is going to be constructors. Now, our constructors will all have the same name as our type, actually, but these methods will be named the same, but we can have different parameter lists, and then we can do different things with multiple constructors, and that'll be overloaded because they'll all have the same name, but different parameters. So the next term that I want to talk about is extends. So what's going to happen when we create a subclass off of the superclass? We'll end up using a keyword called extends, and then we'll extend the base class. In our person worker example, we would have person, and then we would have our subclass, which is going to be public class worker extends person. And then we have implements. And this is the case when we're working with interfaces. So as we're working with classes and we extend a class, we use the extends keyword. But if it's an interface that we're trying to implement, then we use the implements keyword. So instead of having a superclass, the class that implements an interface will be the first class that has the fully defined methods for that type. And the type will be defined in the interface. We're also going to run into the keyword abstract, and this is actually going to be used in two different places. The first place we'll see this is going to be a different type of class. we can create an abstract class, which, similar to an interface, will have method stubs, but also can have methods actually defined in an abstract class. Additionally, we can mark a method as abstract. Now, this will happen in the abstract class. It happens inherently in the interface, but in the abstract class, we'll specifically define a method as abstract. But that means this keyword will enforce that the subclass that extends the abstract class will have to implement this method. So the next term is polymorphism. Now, this is a really big keyword, especially when you go to interviews. What is polymorphism? How does it work? How do you use polymorphism? Basically, polymorphism gives us the ability to interchange objects. So we can write code once, and then we can have multiple objects working in that same line of code. We'll start by coding to the interface, and by doing that, we'll code against the abstract type or the interface type, but all of our subclass objects or extending objects or implementing objects would be able to be easily interchanged into that code, and that's polymorphism in action. Again, working against the base class level would be doing the same thing. In this case, the person, we could put a worker into that, or a student, or an instructor, or a construction worker, or whatever our objects would be underneath person. And we could work with all those objects as an interchangeable person. And the final term that I want to look at today is instance of. Now, instance of is a keyword, and that's going to be used to help us determine if an object is a specific type. For example, if we were working at the polymorphic level, where we had a bunch of person objects, we would need to use instance of to determine if that object was actually not just a person, but a worker, or any of the subclass types. So as long as we need to go in our downcast direction, we should also be aware of instance of being very important in order to determine exactly what we should downcast to. And again, we'll continue to see all of this as we continue our study of object inheritance, interfaces, abstract classes, and polymorphism.